Hello friends, welcome to my channel. Here solve code problems and prepare to the code interview. Today's problem number 907, sum of subarray minimums, medium level. Given an array of integers r, find the sum of min of b, where b ranges over every contiguous subarray of r. Since the answer may be large, return the answer modulo 10 power 9 plus 7. So what we need to do, let's check the example 1. We have a list of 4 items, 3, 1, 2, and 4, and we need to find all subarrays, and we need to contiguous subarrays, and find the minimums of each subarrays, and return sum of it. How we can find subarrays? We can start from each item, its start index, and add new items one by one. So for example, starting from index 0, we can get subarrays 3, 3, 1, 3, 1, 2, 3, 1, 2, 4. Starting from 1, 1, 1, 2, 1, 2, 4. Starting from 2, 2 and 2, 4, and just 4. So it's all subarrays, and we need to find minimums in each subarray. So it's 3. Next 3 subarrays have minimum 1. So 1 plus 1 plus 1. In the second line, we have 3 subarrays, and all of them has minimum 1. So it's 3, 1 plus 1 plus 1 plus 1. Next line has 2 times, and the last line has 4. So let's calculate the totals. We have 6 ones and 3. It's total 9, plus 2, 2 and 4. It's 8. So 9 plus 8, it's 17. 17, and you can see 17 is the correct output. So we need to find it. How we can do it? We can do it straightforward, use brute force solution. We can start from each index, for instance from index 0, 1, 2, 3, and get the last index. Last index each time is the last index of initial array. It's number 4, and check each item and add it to the subarray starting from the sum index, and we need to find minimum of these subarrays. So let's get this solution. It's quite simple. So create result variable, 0 by default. Next, for start, it's start index of our subarray in range n. In our case, n, it's the length of initial array r. The inner array for end in range, it's the end of subarrays from start to n, and inside them we have subarrays. Subarray can be obtained in Python using slices. So from start to end plus 1, because slice doesn't include end item. So we have this subarray, and we can find the minimum using function min of this subarray and add it to result. So, and finally, just return result modulo 10 power 9 plus 7. So that's it. That should work. Yes, it works, but it's very inefficient because we use two loops, two nested loops, and it's n square time complexity, and else to find minimum of each subarray, it's also linear time complexity, so total time complexity of n cube, it's huge. But here we can find some optimization to reduce time complexity to n square. How we can do it? In a loop, we find minimum of all subarray, but we have subarrays starting from the same position, and we add one item each time. So instead of check all subarray, we can check minimum value of previous subarray and check if new item less or not than previous minimum and update it. So let's do it. Let's define min val, its minimum value, and its value of first item, r of start. And inside in a loop, just update it. It's minimum of current min val and current item, and just add it to result. Let's check tests. It seems the same, but it's quite better, and now the solution has time complexity of n square, but it's still not good, and we can submit it because we will have a time limit. We can do it better way, but how we can find minimum in this array. So for instance, if we have some number, for instance 1 is the minimum of whole array, and also we can consider when some item can be the minimum of some area inside array, and its minimum for whole numbers to the left and to the right before some number that less. For instance, if we have some array like this, and now we check 1, it's the minimum of subarray until 0 to the left and 0 to the right. So we have subarray where 1 is the minimum. It's subarray 3, 1, 2, 4. How we can find the sum of minimums of this subarray? So to find all combinations where 1 is minimum and in it's included, it can be some subarrays like 3, 3, 1, just 1, 3, 1, 2, 1, 2, 1, 2, 4. And 3, 1, 2, 4. Just 6 values. How we can find the number of these items? So the final result actually is the sum number multiplied by value. So in our case we have n, its number of subsequences, it's 6, multiplied by 1, it's the value of 1 of the item, it's 1. So final result is 6, and we can find this number for all items in the initial array. But how we can find the how many subarrays can include some number, for instance 1? So how we can find 6? It's actually quite easy. We can consider items to the left and to the right from some number from 1, and get all combination between left and right parts. So we have like 3 item or 2 item to the left, it's 3 and 1, and 3 items to the right, 1, 2, 4, and its multiplication, it's the result. In our case it's 6. So the next thing, how we can find how many items not less to the left and to the right. We can do it using some method calling monolithic stack. What we can do, let's consider smaller list. We can define some stack. So stack is a data structure where we can add or remove some items from the end. So it's like stack of plates, and we will add to the stack structure of 2 items. First item is just value of item, and second it's count how many items to the left or right not less than this item. And let's do it. And also we need to fill right and left lists. So left list contains all counts for each index, how many items not less than current. And so let's do it for the left part. First item 3, just add it to the, let's define like this stack. Add to stack 3 and 1 because stack is empty and we just append it. 3 its value, 1 it's because 3 it's 1 has itself in the list, and add count to the left part. Next item 3, it's less than previous item, so we remove previous item from the stack and add 1 instead of, and count its previous count for 3, it's 1 plus 1 for current value, because now we have 2. For the 2, it's greater than, so just append it. 2 and 1. And the same for 4. 4, 1, 1. It's left part. And the same thing so for the right part. But for the right part, we will check all items from the end to the beginning. So first item it's 4 and the 1 itself, and add it to the right. We need to fill right from the end to the beginning. So next number it's 2. It's less than 4, so we replace it and increment count 2. And we will add it to beginning. So next it's 1. It's also less, so update and add count 3. And last 3 it's not less, so just append 3, 1, 1. So now we have left and right paths and the initial list itself. And final result equals to multiplication of left and right paths multiplied by current value. So first item has 2 1s and 3, so it's 3, plus second 6 multiplied by 1 plus 6. Next 2 multiplied by 2, it's 4, and next 1 1 and 4 4. And final result it's 6 plus 4 is 10, plus 7 it's 17. It's the correct result. So that's it. We need to implement it. Let's clear. What we need to do? We need to define some new variables. It's left and right paths and stack. For the left and right path, let's define array with list with zeros. So and zeros for the right part and empty list for stack. Now we need to find the left part. How we can do it? We check each item. So for I in range n. Next, defined count value. Default count is 1. And check stack. If stack not empty and current value less than last value in stack, last value can be get that at index -1. And index 0 is value because we keep value and count in the stack. In this case, increment current value count, we need to remove the value from the stack. We can use method pop and use index 1, its count, and add it to the current value count. And finally, we removed all items which less than current value, and we need to add current value, so it's r of I and current count. And also let's add it to the left at index I value count. And we can do the same for the right part. We need to clear stack and just copy whole thing and few small changes. First of all, we check all items from the end to beginning, to index -1 with step -1. And with code, return items in backward order from the last to the first item. Count one the same, all the same except left should be right. And now we have initial array R and two arrays left and right, as I discussed before. Now we need check all items again from 1 to n and add it to result. I add to result multiplication of current value, multiply value of count of left part and count in right part. So just that's it. And let's check it. Is it correct or not? Some small error. Yes, small mistake. Append function and the same below. Check test again. It works. Submitted. Yeah. We can here. We need to include one of two parts, first or second, and use less than equals to do it in correct way. We need it because if we don't do it, we didn't we don't include the last item. You can, if you can see the example that failed, it has two items 55, and when we check only less condition, the last 55 doesn't include. So we need to add less or equal in one of two conditions, one of two parts, left or right. So now it should work. Yes, it works. It's pretty efficient, and now it has a linear time complexity instead of cubic that we had before. That's it for today. You can find whole solutions of three kind of solutions in my GitHub repository. Thanks for watching. See you tomorrow. Bye.